All right, this is chapter properties of atoms in the periodic table, and this is masses of atoms lecture and notes. Atomic mass. The nucleus contains most of the mass of the atom because protons and neutrons are far more massive than electrons. Remember, my protons and my neutrons are in that nucleus, and orbiting the nucleus is the electrons. All right. And protons and neutrons are way more massive than an electron. So most of the mass is in that nucleus. The mass of a proton is about the same as that of a neutron, approximately. Remember, each one is made up of three quarks. Okay. Protons are made up of three quarks, and neutrons are made up of another combination of three quarks. The mass is not exact, but it's close enough when they're that small that we consider them the same. Little Spider-Man for you. The mass of each, that's the mass of a proton and the mass of neutrons, are approximately 1,836 times greater than the mass of an electron. Okay. And because of this, we do not consider electrons in that atomic mass. So the unit of measurement used for atomic particles is the atomic mass unit, or the AMU. The mass of a proton or a neutron is almost equal to 1 AMU. All right. The atomic mass unit is defined as 1/12 the mass of a carbon atom containing 6 neutrons. All right, so the atomic mass unit is defined as 1/12 of the mass of a carbon atom containing 6 protons and 6 neutrons. What does this mean? Let's bring up our periodic table and take a look. All right, so these numbers right underneath, and let me see if I can find right here. Here's our numbers, our mass numbers, 12.011. Carbon is 12.011. All right. Now, this atomic number up here in the corner in a neutral atom, and you're going to hear me talk about neutral and balanced atoms coming up. There are 6 protons in carbon and 6 neutrons and 6 electrons. Okay. So my mass, if I have 6 protons, my atomic mass units, 6 protons, 6 neutrons, 12, right there, 12. I have 12 as my atomic mass, right? Now, the reason we use a carbon atom, because for there to be life, whether it's a plant, an animal, whatever, organic material, living material has to have carbon, okay? It has to have carbon. So that means that is the basis for life. So we use that atomic mass unit and we base it off of carbon. So let's go back and look. The atomic mass unit is defined as 1/12 the mass of a carbon atom containing 6 protons and 6 neutrons. Okay. It has 6 protons, 6 neutrons. It has a mass of 12. An atomic mass unit is defined as 1/12 the mass of carbon. Protons identify the element. The number of protons tells you what type of atom you have and vice versa. For example, every carbon atom has 6 protons. Also, all atoms with 6 protons are carbon atoms. So again, let's pull up our periodic table. This one's a little easier to read. There's not so much writing on it. So right here, carbon is number 6. That's its atomic number. That means it has 6 protons. And nitrogen has 7 protons. If we go down here, iron, where's my iron at? Iron. Why can't I find it? Right here? Iron. Iron has 26 protons. Bismuth has 83 protons. Barium, 56. Okay. And you'll notice as I go from left to right, I increase in the number of protons. Okay. I increase in the number of protons. So that atomic number right here tells us how many protons there are. Now, neutrons are not always equal to the number of protons. If we look, for example, right here at zinc, the atomic mass is 65. There's 30 protons. Protons plus neutrons give me my net mass number. So there's at least 35 neutrons in an atom of zinc. Okay. 30 protons and 35 neutrons. But in these cases up in here, it's usually pretty close to the same. Oxygen, 8 protons. Mass is 16. So most of the time, oxygen has 8 protons and 8 neutrons. Okay. When they have different numbers of neutrons, they're called isotopes, and we're going to take a look at that. So remember, the number of protons tells you what type of atom you have. And that number on the periodic table right there, we were just looking at, that number, the atomic number tells us how many protons there are. Here's my atomic number here. Okay. Tells us how many protons. How many protons. The number of protons in an atom is equal to the number called the atomic number. The atomic number. And once again, I know I keep going back and forth, but this is my atomic number. 81, 82, 83, 84. It's the same thing on this one. 81, 82, 83, 84, right here. Okay. All of these, the atomic number is the number of protons. Right. The mass number. The mass number of an atom is the sum of the number of protons and the number of neutrons in the nucleus of an atom. If you know the mass number and the atomic number of an atom, you can calculate the number of neutrons. Number of neutrons equals the mass number minus the atomic number. Number of neutrons equals mass number minus the atomic number. So if we need to find out the number of neutrons, and in this case, we'll just round it. So right here, here's my mass, 15 of oxygen, 15.98. We'll just say that's 16. 16 minus 8 is 8. So 8 protons, 8 neutrons. I did the same thing with zinc a minute ago. Let's look at lithium over here. Lithium, 7, 6.94. We would round that to 7. 7 minus 3 is 4. So lithium has 3 protons and 4 neutrons. All right. You take the mass number and divide and subtract the protons from it, and that gives us our number of neutrons. So you're in the case of beryllium, 9 minus 4, 5. We would have 5 neutrons. Isotopes. Not all the atoms of an element have the same number of neutrons. Atoms of the same element that have different numbers of neutrons are called isotopes. How do we identify an isotope? You use the name of the element followed by the mass number of the isotope to identify each isotope. For example, boron 10 and boron 11. So let's take a look at boron real quick. Here's boron. And notice it's 10.811. That's the average atomic mass. Okay. So because there's 2 different versions of boron, we have an average. Now look, if you see this number right here, 10.8, that is closer to the number 11, right? There are boron 10 and there's boron 11. There's more boron 11 out there than there is boron 10. That's why my average is closer to 11 than it is to 10. If they had equal number of isotopes out there, equal number of boron 10 and boron 11, this would be 10.5 because 10.5 is in between 10 and 11. But in this case, there is more boron 11 out there. All right. Those are isotopes of each other. And here we go. Here's boron 10. It has 5 electrons. Boron 11 has 5 electrons. Boron, you're going to want this too, because I believe in the homework. This is a homework question. It'll say something about comparing isotopes. They have the same number of electrons. They have the same number of protons. The difference is the number of neutrons. Boron 10 has 5 neutrons. Boron 11 has 6 neutrons. And remember, these are isotopes of each other. Isotopes. All right. When they have different numbers of neutrons, they're known as isotopes. The average atomic mass of an element is the weighted average mass of the mixture of its isotopes. For example, 4 out of 5 atoms of boron are boron 11, and 1 out of 5 is boron 10. To find the weighted average, or the average atomic mass of boron, you would solve the following equation. Now listen. These notes, I've been using these notes for years. We used to have to know how to calculate this for the old OGT test. You do not need to know how to calculate this any longer. But there's the calculation. Questions. How is the atomic number of an element determined? The atomic number of an element is determined by the number of protons. The number of protons. The element helium has a mass number of 4 and an atomic number of 2. How many neutrons are there in the nucleus of a helium atom? Well, you take the mass number, 4, and subtract it by the atomic number 2. 4 minus 2. How many neutrons are there? 2. How much of the mass of an atom is contained in the electron? We consider an electron negligible. It has such a tiny little mass, we don't count it. So how much of the mass of an atom is contained in the electron? 0. No mass at all. Remember, the mass of an atom is its protons and its neutrons. When I add those together, I get the atomic mass. All right. I believe that is it for this lecture and this note. I hope this helps.